Hello, friends. Welcome to Science Talk. I'm your host and resident oceanographer, Jim Massa. Okay, I want to share with you this what we see right here. Observe changes in the Arctic freshwater outflow in the Fram Strait. Now, again, it's another lengthy paper. I'm just going to uh, share with you some of the underlying concepts and background information, our knowledge to this point by going through the introduction. Then we'll look at the abstract and we'll discuss that. Uh, it's a lengthy paper. They spend a lot of time on the methods, how they did the mooring station, they developed the models and all the, the equations, et cetera, et cetera. That's really not germane to what I want to discuss here. I will leave the URL in the comments section for those who do wish to take a look at it. So let's pop down to the intro and let's go from there. The Arctic is experiencing rapid changes related to anthropogenic climate change. Arctic warming and rising air temperature lead to a more intense hydrological cycle and rapid ice retreat. Now, that's a loaded statement that gives a lot of truth to what's happening. Arctic warming and rising air temperature lead to a more intense hydrological cycle and rapid ice retreat, leading to increased liquid freshwater input to the Arctic Ocean. So basically, you got warmer air, you increase the humidity you got warmer waters, increases the humidity in the air above, and you get increased precipitation events. Okay? Fresh water, both liquid and sea ice, circulate in the central Arctic Ocean with the surface currents and exit through the Fram Strait in the Canadian Arctic archipelago. And they reference you to Figure 1, which we'll take a look at in a bit. That's Figure 1 there. Freshwater anomalies entering the Nordic seas and subpolar North Atlantic may modify dense water formation and therefore the strength of AMOC, the overturning circulation. And I've discussed that with you countless times before. I think we understand the process involved there. So far, however, measurement of the AMOC revealed strong variability, and the current length of the time series has been shown to be too short in order to identify a significant trend. Okay, meaning that if there's a cyclical nature to it, it's too long for us to have spotted it yet because our data record is not sufficiently long enough. Okay, so we analyze the Arctic freshwater outflow through the Fram Strait that reflects changes occurring in the central Arctic Ocean, precedes variability in the Nordic seas and subpolar North Atlantic. So this is what they're talking about here. Outflow this way. Here are the Nordic seas, sometimes referred to as the Greenland, Icelandic, Norwegian Sea, sort of the Jin Sea. But there's the Nordic Sea. The lighter blue, that's all your shelf system, right? So you got your Barents, your Kara, your Laptev, your East Siberian. This is all your shelf system. This is the East Greenland Shelf, by the way. And that's what this EGC is, East Greenland Shelf. So we got all these mechanisms going on. There's Novaya Zemlya, right? Franz Josef Land, etc., etc. So they're talking about movement right this way, ice, fresh water, what have you. Purple arrows indicate the suggested pathways of fresh water in the central Arctic Ocean, East Greenland Current. The purple dashed arrow over the Greenland shelf suggests the pathway of polar waters transported over the shelf and was not observed, basically. So that's these guys here, the solid line here, and so on. But overall, the circulation pattern is you have the BG, that's the Beaufort gyre, that goes clockwise. The water flows in this way, intermediate depth, comes around, and then comes this way and right out there. And don't forget, the Arctic dipole is going to control whether the circulation stays in the Arctic Ocean or is pushed out the Fram Strait. Okay, Continuing on, the Fram Strait lies between northeast Greenland and the Svalbard archipelago, is the largest and deepest gateway between the central Arctic Ocean and the Nordic Seas. The deep part of the strait has a maximum depth around 2,600 meters, which is respectable, and steep slopes connected to the much shallower continental shelves of Greenland and Svalbard. Following the continental slope on the western side of the strait, cold and fresh polar water and sea ice are exported from the Arctic with the East Greenland current. Along the continental slope to the east, the West Spitsbergen current brings warm Atlantic water to the central Arctic Ocean, while branches of the Atlantic water recirculate within the Fram Strait and flow southward along the polar water. The East Greenland current carries about half of the liquid freshwater export to the Arctic of the Arctic Ocean, no, excuse me, not to, but of the Arctic Ocean, and nearly 90% of the sea ice. So let's just pop back up here, explain what they're talking about here. The purple arrow is that polar water going this way on the west side of the strait. These yellow arrows are you can see some branches this way and going this way, but the yellow arrows are the warm Atlantic water moving into the Arctic Ocean on the east side of the strait. That's what they're talking about. Freshwater content in the ocean is defined as the amount of zero salinity water required to reach an observed salinity, starting from a chosen reference value. And that's all. They develop that in the methods there. But it's basically where we start seeing is a dilution in the salinity. So that has to be a freshwater infiltration, a little bit of mixing going on. And then they report that Rabe et al. In 2014, using both observation and model data, reported a rapid Arctic-wide increase of the freshwater content between 2000 and 2009. The increase was accompanied by the intensification of the Beaufort Gyre, leading to a convergence of freshwater in the area, and possibly to a reduction of the Arctic freshwater outflow. So, what they're talking about here is the Beaufort Gyre. So that this increase in intensity and help constrain more fresh water. I would submit that the Arctic dipole had a role in that as well by impacting, directing the surface currents so that the flow stayed in the Arctic Arctic Ocean and not pushed out through Fram. And they go on to say that between 2009 and 2015, the spin-up of the Beaufort Gyre and the freshening Canadian basin equilibrated and found some sort of balance. But since 2016, the freshening continued. The last record of the observed liquid freshwater outflow through Fram Strait showed a period of increased freshwater transport between 2015 and 2015, concurrent with the equilibration of the Beaufort Gyre and accumulation to a significant freshwater volume anomaly, which then impacts what happens in the Nordic seas where AMOC basically forms. It is unclear if the freshwater transport in the Fram Strait continued to increase or if it has decreased since 2015. So they go on to say how in the paper they're trying to address freshwater transport estimates. Okay, so what do they find? Let's look at the abstract. We have updated time series of liquid freshwater transport in the East Greenland Current in the Western Fram Strait with mooring observations since 2015. Novel data has been used to correct earlier estimates when instrument coverage was lower. The updated freshwater transport reference salinity 34.9. That's actually kind of high. That's more Atlantic ocean values. The Arctic ocean value tends to be around 32. That's interesting that they went with that reference salinity. But that's, as I just said, that's Atlantic water. Shows that the increased export between 2010 and 2015 has not continued, but freshwater transport has decreased to pre-09 levels. Salt transport independent of a reference salinity is shown not to be sensitive to salinity changes. Between 2015 and 2019, the freshwater transport in the polar water decreased to an average of basically 60 plus or minus 4.5 microsphere drops. So I guess microsphere drop is 1,000th of a sphere drop. So that would be 10 to the third. instead of 10 to the 6 cubic meters per second, which is 15% less than the 2003 to 2019 long-term mean. However, high freshwater transport events occurred in 2017. The overall decrease is related to a slowdown of the East Greenland current, partly attributed to a decrease of the zonal density gradient. If the gradient weakens, the flow weakens. Think of, if you have a strong pressure gradient, move from very high pressure to very low pressure, and air moves down the pressure gradient, you have very strong winds. As the pressures equilibrate or get closer to each other, the winds decrease, the velocity decrease. Well, that's kind of the concept, the principle here. And so why did this zonal decrease in the zonal density gradient? Due to stronger salinification of the halocline waters, which is about from 26.5, and that's sigma theta. And sigma is what we use for salinity. So from 26.5 to 27.7 kilograms per cubic meter. Over to show. This salinification counterbalances the freshening of the surface water. So you have the saltier, you have the increase in salinity that's counteracting the increase of fresh water to the system. And freshwater content decreases. Our results show changes in the polar water between 2003 and 2019. Salinity stratification increased as the salinity difference between 155 and 55 meters increased by about 0.63 PSU, practical salinity units. The polar water layer became thinner by 40 to 50 meters, and the polar Atlantic front moved about 10 kilometers west in June 2015. All processes, this is important, and I've discussed this with you in countless videos before, all processes point to an Atlantification of the western Fram Strait and a reduced polar outflow. That right there. The Atlantification of the Arctic Ocean continues. So that probably explains why they use 34.9 as the reference salinity and what they meant by the salinification counteracting the freshwater input. And what we've been seeing is that this Atlantification is affecting the halocline. Don't forget, this warm Atlantic water that's salty is coming in at intermediate depths. So therefore, it is making the halocline in a lot of places get shallower, pushing up. So now let's look at the plain language summary. The East Greenland current brings fresh and cold polar water southwards from the central Arctic Ocean. In the Fram Strait between Greenland and Svalbard, the strength and properties of this current have been observed using moored instruments since 1997. We present updated time series for the 2015 to 2019 period and reanalyze earlier variability and estimates. Our results indicate that the freshwater transport since 2015 has decreased, however, with an exception in 2017. This general decrease is caused by a reduction in the southward flow speed and the amount of fresh polar water. The front between polar Atlantic water has moved westward. Polar water layers become thinner and more stratified. However, the amount of Atlantic water in the section increased, pointing to an Atlantification of the western Fram Strait. We also refined the time series of the East Greenland current back in time based on the new data, calculate the uncertainty, and show how it depends on the amount of instruments. Basically, more instruments you got, more data you get, and allows you to get a more complete picture. Finally, we evaluate possible drivers of the observed changes and discuss a connection with Arctic freshwater storage. Now, I've done videos in the past where I discuss, get all this freshwater input. What will be the fate of it? Will it stay in the Arctic Ocean? And if it does stay in the Arctic Ocean, does it get mixed? Or does it get pushed out through Fram Strait towards the Nordic Sea and towards where AMOC typically starts forming? Well, this study seems to indicate the former, that it's going to be constrained within the Arctic Ocean, and it's going to probably be mixing a bit, the salinification they refer to, and that because the gradient is decreasing, the amount that gets pushed through the Fram Strait will also decrease. That's basically what they're saying. So according to this study, and based on prior videos I have done in the past, where I discuss what will happen to the freshwater buildup in the Arctic Ocean, it seems to be that for now, at least through 2019, with the exception of 2017, it's staying in the Arctic Ocean. And in some ways, it's mixing so that you get this, so you have the increase in salinity, the salinification, and this is all being affected by the increase. We know that the inflow through Fram of the North Atlantic intermediate water is increasing, so that we have an overall Atlantification of the Arctic Ocean. And I did that two-part video. I was talking about how the Barents and the Carices are getting Atlantified, as this front is just moving through the Arctic Ocean. This is further information that further builds on analyzing what the dynamics are going on. So this is one of these things where stay tuned. Thank you for your time. Hello folks, this is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.